In triangle ABC, we're told that angle A is 75 degrees, and side B, which would be across from angle B, is 12, and side C, which would be across from angle C, is 10. And we want to solve the triangle. So to solve the triangle, note that we are given a side, the included angle, and another side. So when the information given to you is side angle side, the appropriate rule to use is the law of cosines. So we're going to start out by finding side A, which would be across from angle A. So A squared, which is what we're searching for, would equal 12 squared plus 10 squared minus 2 times 12 times 10 times the cosine of 75 degrees. That means that A would be equal to the square root of that amount. 12 squared plus 10 squared minus 2 times 12 times 10 times the cosine of 75. Notice in setting up this formula that when I'm looking for side A, angle A is what's used in my problem, and the other two sides, the 12 and the 10. And it really doesn't matter in which order you write those. So to find side A, we're going to get out our calculator and we're going to take the square root of 12 squared plus 10 squared minus 2 times 12 times 10 times the cosine of 75, and that means that side A turns out to be 13.486. So now we want to find angle B and angle C, and we can certainly use the law of cosines for angles like we did in the last example. Or, because we now know an angle and the side across from it, we could go back and use the law of sines, a review from the previous lesson. So that's how I'm going to work this problem so that we can go back and review. So I would know that the sine of 75 degrees over the side across from it, 13.486, would have to equal the sine of angle B divided by the side across from it, which is 12. So 12 times the sine of 75 degrees, if we cross multiply, equals 13.486 times the sine of angle B. So the sine of angle B is equal to 12 times the sine of 75 degrees divided by 13.486. So that means that to find angle B, we would have to use the inverse sine function on our calculator. So second sine of 12 times the sine of 75 divided by 13.486 gives us that angle B would equal 59.260 degrees if we round it to 3 decimal places. Now we could do a similar law of sines to find angle C. We could use the law of cosines to find angle C, but we know that the three angles in a triangle add up to 180 degrees. So 180 degrees minus 59.260 added to 75 degrees will give us our measure for angle C. So entering that on our calculator, 180 minus 59.260 minus the 75, if we distribute our negative, would give us that angle C is 45.740 degrees. So we have found the missing angles in our triangle and the missing side using the law of cosines.